Hello and welcome to this lecture about parametrized test. The idea of this lecture is to show how we can reuse test logic with a lot of different values, how we can run our test with all possible combinations of these values, and to doing so, to present the parametrized test, we are going to use an IO example that shows the power and how we can complete these two goals. Let's start with a simple problem. We have a simple test that asserts that summing two different fractions give us the correct number. But this test only tests this specific case with these specific values. So we need to have a way of generalize it to make it more powerful and to cover more cases, so we are more sure that our code is good and we can continue implementing new parts of the system and having always the assurance that this test will work. So how we can reuse this test to execute for more values? Well, this is the idea that we will want to have different values for executing. The first attempt that we can do is using a collection, with two collections inside, where we have the two operands of our test. So we are going to, in the first iteration of this collection, we are going to take the first operand, the second operand, and the result. And for each of these triplet, we are going to execute the assert. And we are going to test that our sum is working as we want. But if we want to have more tests that reuse the same idea, we will have to repeat the same code pattern everywhere. And we will have to repeat the values that we are given and the configuration that we are given to all the tests where we want to reuse it. And as we always say, we don't want to duplicate code. We don't want to duplicate, in this case, the loop. Also, as you see, the complexity of this test has raised a lot. We passed from a single line test to a loop and a collection and values, and this test started gaining complexity easily. So, what is the solution that we are proposing in this lecture? Is the idea of using parametrized test. Basically, a parametrized test is a test case where we can put from outside different set of parameters to execute more and more cases. Basically, what we are going to come back is to having our test method in the same sense that we had before. Just in this case, we are going to replace the constant with instance variables. We are going to have a number 1, a second number, and the result, and we are going to sum the two numbers and compare it with the result. We are going to define our test case class inheriting from parametrized test case. Usually remember that when we define a test case class, we extend from test case. In this case, we are going to use parametrized test case. And we are going to define the instance variables that we need for this test. So once we have the test written and the instance variable that will collect our values, we have to give the different values that we want to have for these cases. We are going to come to the class side of our test class and define the method test parameters. This method test parameters will return a parametrized test matrix. Basically, this object is the one that has the responsibility to contain all the cases that we are going to execute. In this first example, we are going to add the cases one by one. You see, in this, we are adding the first case for our test, where we have the first number will be a 2, the second number will be a float 1.0, and the result should be a 3. And then we added a second case with the fractions as they were before. So we have extended our test cases with these two cases. One for the integers and float, and one for the fractions. If we added more and more classes, it will more and more cases. Sorry, the cases will be added in this method. Well, what are the benefits of this? Well, basically that our test continues being the simplest one that we can write. We can reuse this by using the accessing to the variables, and we can rewrite different tests. In this case, we are going to write a test for testing in a different way, but we can reuse it. We should call this test minus. And the idea is that we can use these instance variables with the different cases in different tests and reuse them. So every time we add a new case, will affect to all the test methods that we have. So we can execute our test with different configurations, and we can always add new configurations to cover more and more cases in a more clean way than adding it to a collection. Let's see another problem, another variation. Let's see if we have test to testing collections, to testing an object where we can enclose different objects inside. In this case, we are going to write the simplest one. We are starting testing first a collection of the class bag, and we are adding, yes, the string A. Once we add the string A, we can ask the collection if it includes this object, and we can ask the collection its size, and it should be 1. We have the asserts written for our test. This test is perfect. It has exactly what we want, but the problem is that this test is limited just to one kind of collection and one kind of element inside. So let's try to do it a little more generic. And the first change we can do is to introduce an instance variable holding the collection class that we are testing. We are going to execute this test with many collection classes. We are going to create many kinds of different collections, and we are all testing them with the string to see if we can put in a string inside and if the size is correct. So we do exactly the same. We have to extend from parametrized test case and add the instance variable collection class. Up to here is normal development as we were doing before, and the idea now is that we are going to provide the test parameters with different cases. In this case, we are going to say a little more complex but more flexible message to test matrix is that we are going to say for the selector for the instance variable that we are going to access through collection class, we are going to give different options. In this case, we are going to give set, bag, and ordered collection. What it will do is that it will run all the tests, first with set, then with bag, and then with ordered collection. In this case, we have extended our test case from only testing with bag to include other kinds of collections. But what if we want more? What if we want also to change the kind of object that we are storing in the collection? In this case, we are only using strings, but we want to test also with numbers, other objects, and different elements inside. So we can test that the implementation of collection can support more than strings. So let's do exactly the same. Now we are going to keep the item as an instance variable, and we are going to create a setter for it. And we are going to use this instance variable in the test instead of the constant value as we had before. So once we added the new instance variable and we are using in the test, we have to declare in the test parameters that we need to add different options for this new instance variable. We do it in the same way that we have done it before, configuring the test matrix, the parameterized test matrix object, with saying that for the given selector, in this case item, we are going to add 3 different options. The number 1, the string A, and the character C. In this case, the test will execute for all the combinations that we have in this test matrix. Will produce the combinations to execute the test in all the possible values. It will take a set and it will test it with a number 1 and a string A and a character C. Then we'll take the bag and we'll do the same with the 3 others, and then we'll take the ordered collection, doing the same for the 3. So it will execute 9 cases. It will generate the 9 possible cases. It will run all possible combinations of these options. In this case, we'll combine the 3 of items and the 3 of collection class, having 9 tests in total. So, as a conclusion, parameterized tests are handy when we want to repeat the same test for different values, when we can generate all possible values and explore better the space of our solution, so we cover more and more cases and we are safe that our code is working for more and more cases. Also, it's a good way of organizing all these cases, organizing all these different values and combinations in a way that is more flexible and that we can maintain easily in the future.